Hi, my name is Rajiv Dave, and this is my first article on IoT architecture. So today I will explain in detail the IoT architecture in this video. Keep watching this and let me know your feedback. Thank you so much for watching. Bye. So this was the figure which I presented earlier. So today just I'm trying to show you or discuss with you in detail. So let's first make sure that we are on agreement on meaning of IoT. So the official definition is interconnections via the internet of everyday object and enabling them to send and receive data. IoT involves all sort of devices from watches, TV, phones, and to ovens, refrigerators, and gas meters made smart by being connected and sharing data. So and at the same point, the need to gather this data for mining purpose. So data is everywhere here. So we are talking about the data, how to manage overall data in this architecture. Now in your extreme left hand side, you can see this the things. The things equipped with the sensors to gather data and actuator to perform commands received from the cloud. So the actuator which perform the command received from the clouds through the controllers. So and this things is sending data to the clouds through controllers. So we'll see this. So let me show you here that various type of sensors you can see here: the color sensor, gas sensor, LDR, light sensor, proximity sensor. So here you can see the sensors which this is overall is a sensor, and the further it amplifies, the microwave sensor amplifies and send data to speaker, and the output you can see it here in actuator. So here you can see the sensors sensor is sending a data to actuators, and actuator is sending back data to the sensors based on certain commands, right? So let me go back to the presentation. So I hope the things is clear. Now the most important thing which we will discuss this about the controllers, right? So controllers, actually basically we use this controller for data filtering, pre-processing and moving it to the cloud, and vice versa, and receiving command from the cloud, which I explained earlier. So controller which controls data or filter data before sending it over to the network. So actually we don't want to send all the data over the network. We want to filter data before sending it to the cloud. So this will work as a two-way communication channel in between the things and the cloud. So all action, alert, commands from the cloud to the things is going through the controller, right? So even we can discuss further about the controllers. This is also called a gateway for data filtering, and it performs several critical functions such as device connectivity, protocol translation, data filtering and processing, and security, updating, management, and more. So some sensors generate tens and thousands of data points per second. So the gateway provides a place, the controller provides the place to pre-process that data locally at the edge before sending it to the cloud. So this is very much important that we need to pre-process the data locally at the edge before sending it to the cloud. Why? When the data is aggregated, summarized and tactically analyzed at the edge, so it minimizes the volume of data that need to be forwarded on the cloud. So we need to minimize this data, minimize this particular flow. So we some way we need to pre-process the data, filter it here, which can have a big impact on the response time if we are not controlling our data, and the network transmission cost. So you can see this is the network transmission cost, which is very much important for any architecture. So there is a cost for network, right? So we need to control that network based on the data. This also provides the security before sending it to the network, right? Because the gateway manage information moving in both directions, right? It can protect data moving into the cloud and from the leaks and IoT devices from being compromised by malicious outside attacks, right? So this is this which we covered, that is the things and controller. Now let's come to the cloud. So this cloud we are talking about here. So cloud, we maintain all IoT servers here and handle all protocols. So cloud gateway to ensure data transmission between the gateway, that is controller, and central IoT servers. So this is the function of the cloud only here. So you can see the two flows here. One this is the blue line. Now you can see this blue line, right? And one is this particular line. So you can see this line is coming here and it's going further in this direction. So there are so many lines is here. So here we use the stream data processors to distribute the data coming from the sensor among relevant IoT solution components. So we distribute this data. One data is coming through this here and one is coming through this line. You can see why we are distributing. So stream process all received data, or you can say the events. This typically include integrating different source of streaming data as well as individual data element, normalizing the data, cleansing it, and addressing things like missing data, different format with different rates or different transmission protocols. So here exactly we will maintain all the protocols, all the format which is coming along. Might be the JSON is coming along, might be the XML is coming through this, and any other format, text format. So we combine it and make it a single format to further transmit it. So stream processing has detected an event and action is required, right? So this send notification to the responsible person or system workflow and can trigger an operational system to perform a prescribed action. So here you can see the second point here. This is a point. So here exactly we are taking some actions based on the data which we are getting from this stream. Now let's have some example. This can include stopping a machine. I want to stop the machine because of some reason. I want to change the temperature setting because of some reason. I want to change the temperature setting of this particular thing because of some reason. Activating vehicle brakes. I want to activate the vehicle brakes, and changing street light intensity. So these are the actions which we can perform directly from here through this action alert application. Now let's come to this particular this line we will discuss, that is a stream, and stream is sending back this all the data to the data lake. Now data lake is collecting all the data, defined and undefined values, right? Is collecting all the data. Now this will store all data has been for the long term. If we need the data in meaningful format, we will load it to the big data. Now this is the big data warehouse where exactly we are collecting a valuable data, right, which maintain the filter and meaningful data, right? A big data warehouse contains only cleaned, structured, and matched data, right, compared to the data lake, which contains all sort of data generated by the sensors. Also, data warehouse stores context information about the things and the sensor. For example, where a sensor are installed and the command control application sent to the thing. So here you can see the big data warehouse which contain the logical or meaningful data. You can see not the logical, it's a meaningful data. Now let's go to this big data. It's sending this data to the business logic, and here we are performing some logic here, and you can see the web application and mobile application. So mobile and web application is performing some business logic on the big data and taking some actions on the thing. So you can see it's sending back the data to the action alert application so that it can take some action. Now you can also see this particular line. So big data is sending a data to machine learning. So with machine learning, there is an opportunity to create more precise and more efficient model for control application, right? This model for control application, right? More precise. Models are regularly updated. So these are models which we can regularly update. For example, one in a week or once in a month based on the historical data accumulated in the big data, right? So machine learning is performing all these actions. When the application, when the applicability of the efficiency of a new models are tested and approved by the data analyst, new models are used by the control application. Here, new models can be used by the control application to take certain action on the particular data. Alert application, right? This is the alert application and send automatic commands and alert to the things. This is the alert application, right? You can also see data is going to this analytics sections. So in analytics section, you can see this, we are performing some analytics on this particular data, right? You can create some report and any other analytics on this particular data, right? So these are the various things which we can perform here for reporting purpose, right? Now you can see there we can utilize the three more applications, that is edge management, user management and security management. So we will see in detail in our next video. On the extreme right hand side, you can see the tools and technology which we can use in building this architecture. So you can see the Apache Spark, Spring XD, JMS, MQTT, Mosquito servers, Apache, Kafka, MongoDBs, Gemfire, Python, Jetty, Hadoop, Cassandra DB, Zeppelin, Dockers, Redis Cache, Kubernetes and Apache Storm. So these are the tools or technologies which we can use to build this overall architecture. I'll explain each and every technologies in detail in my future videos, that how exactly we can use the Apache Spark, how exactly we can use the Apache Kafka, where exactly we can use the Apache Kafka, where exactly we use the MongoDB, where exactly we use the PostgreSDB, or where exactly we can use the Gemfire, right, in building this IoT architecture. So next plan we will discuss further IoT architecture part 2, where I'll discuss about the database, hot and cold database. I will try to show one more architecture, high level architecture, so it will give you the clear picture where exactly you need to place what thing. And we will discuss about the security, which is very much important for the IoT. Now, and in our next session we will see IoT architecture in action, means we will use tools and technologies to see that where exactly we can use these tools in our IoT architecture, and then we will use the IoT with open source, how I can create an IoT system or IoT application using the open sources. So thank you so much for watching. You can catch me on the Twitter, LinkedIn or Instagram, or send me a mail if you have any questions, suggestions, feedback. Thank you so much for watching this.